We will now proceed with a presentation by Dr. Stanley J. Love titled A Special Place in Space. Following the presentation, Dr. Love will be open to questions from the audience.
All right. So the audio worked when we tested it. Is it still working? You hear me in the back? Yes? Good? Okay. All right. This will be a little bit of a change in gears. When I was invited here, I asked if the audience would want to see video from my space flight, which is what I normally show. And I was told, well, we'd rather hear something on an environmental theme. So I would like to talk a little bit about an environmental theme. You may already know that the Earth is a special place in space, but after this talk, I hope you realize really how special it is. So without further ado, let's get started. There is a story that a lot of astronauts tell, and it goes something like this. When they were growing up, all they could think about was flying. They wanted to fly. So they joined the military, went through pilot training, became a jet pilot, and then maybe the only other thing on their mind besides being a pilot, at least for American astronauts, is their great country and how they wanted to serve their country and to do so when flying. So after a career in the military as a pilot serving their country and flying, a few of them have the opportunity to fly into space, which is like the highest achievement you can make as a pilot, is to get to fly in space on a vehicle that looks like this. But once they got there and looked out the window and saw how amazing the Earth is, how colorful it is, how dynamic it is. You know, even if you fly over the same place 2 days in a row, the clouds have changed, the lighting has changed, the color of the water has changed, the wind patterns on the water. So it's always changing, and the colors are absolutely amazing of the Earth from space. They also have a chance to see what the moon looks like with the Earth. The moon looks kind of small and dirty from orbit compared with the amazing bright blue Earth. The moon is actually really dark. The Earth is very bright and colorful. And then another amazing thing that they'll report is that for the first time, they saw how thin that layer of atmosphere that separates the lively, interesting, dynamic part of the Earth from the sort of dead blackness of space, and how narrow that boundary is. And actually, the part of that you can breathe. Let's see if I can find my pointer here. The part of this you can actually breathe is just barely above the surface. Most of the color that you see here is very high in the atmosphere, and you wouldn't last long if you tried to breathe that. So after these experiences, our patriotic pilots returned to Earth with a new recognition that the Earth is precious. And some of them actually kind of become tree huggers, including some who never had an environmental thought in their life. They were all interested in jets and so forth. And suddenly they became very interested in protecting what it is that makes the Earth special. And this is an actual website founded by two astronauts, at least one of which had never thought about the Earth's environment in their life until they flew in space. And now it's a whole organization and website devoted to protecting the Earth's environment. So this is a great story, but it's not my story. Sorry. So I would like to talk a little bit about my story, and then that will lead into a little bit more about what makes the Earth such a special place in space. So in 1971, before even many of your faculty were born, this book came out. It's a collection of essays about protecting the environment. And the environment was not cool yet in 1971. Now it's cool, 50 years later. Back then, nobody really thought about it very much. But I'd like to point out to you the authors of this book. Glenn A. Love and Rhoda M. Love, those are my parents. So, so before I became a pilot or an astronaut, I already knew about the environment. I was raised by some of the first professional tree huggers in the world. So I already had that awareness before I flew in space. And although I'm proud of my country and what it does, I also have a soft spot in my heart for this flag. Anybody ever seen this one before? You have, yay. Cascadia flag, good. I'm shocked, but you're very well informed. So there is a not entirely serious movement for the west coast of the United States to separate from the rest of the United States and make an ecological utopia. Actually, there's a book called Ecotopia that had that notion back in the 70s again. It's a fun read, probably not good political doctrine, but anyway, it's a good book. But anyway, this has been proposed as the flag for Cascadia after the Cascade Mountains. And that's a Douglas fir tree, and the colors stand for the blue of the sky and the water, the white of clouds and snow, and the green of the environment. So I like this flag. I have a copy of it. All right, so with that background, I went to school. I earned a PhD. I was never a fighter pilot. This is me getting my doctorate degree in 1993 with my mother and sister. And my specialty was planetary science. So my degree is in astronomy, and my specialty is in studying planets. But for me, mostly comets, asteroids, meteoroids, and so forth. Things that are in the solar system and nearby to the Earth, but not the Earth. And this is just sort of a representative picture showing the planets of the solar system and then some of the major moons. And you can see they already took Pluto off of this one since they decided to make it not a planet in 2006. I think they should have grandfathered it in, but I didn't get a vote. So as a young student, one of my role models as an astronomer and planetary scientist was Carl Sagan. He was a planetary scientist at Cornell University and also a great popularizer of science. In fact, many scientists thought less of him as a scientist because he spent so much time explaining science to the public. Let's see, why is that bad? Whose tax money funds all of NASA, ESA, all of research, all of planetary science? Public. So yeah, they should kind of know what they're paying for. So anyway, he was a hero and role model of mine all through school. I was privileged to get to meet him in person when he visited the University of Washington. And there's a great quote from Carl Sagan, which is, anything else you're interested in is not going to happen if you can't breathe the air and drink the water. Don't sit this one out, do something. And this is from 20 or 30 years ago. So Carl Sagan, in addition to being a great student of the solar system, he was also very interested in the environment. And in fact, if you talk to any planetary scientist, you will find they're pretty much green people. They're very, very interested in protecting the Earth's environment. And this may seem odd at first because planetary scientists love technology. We love the spacecraft that would send out to other planets to explore them. We love the telescopes that would gather the information about what's going on in our solar system. We're just interested in technology. You need technology to go exploring outside the Earth. And also, planetary scientists, their interest is outside the Earth. They are very interested in worlds besides the Earth. It's like their main interest. Yeah, the Earth, okay, but this is really cool. This is Pluto. Again, they decided to make it not a planet, and they didn't ask me. So planetary scientists, they love technology, and they love worlds besides the Earth. So why so Earth-friendly? Valid question. And the answer is, because they know what else is out there besides the Earth. And in fact, I think everyone should have a notion of what else is out there besides the Earth. So I want to talk about that for just a few minutes here. And I realize that the only thing standing between you and lunch is me. So we'll try to keep this as brief as possible. All right, so let's take a look at what there is out in space besides the Earth. Closest thing, most familiar to us, is the moon. Immediately, this does not look like the Earth. There's no trace of atmosphere. When you look at the limb against space there's no color, there's no light, there's nothing. It's just the black of space, and you can tell it's completely covered with impact craters. The Earth has had at least as many asteroid impacts on it as the moon. In fact, many, many times more. But because we have rain, wind, water, and plate tectonics and volcanism, almost all of the impact craters on the Earth have been erased. The ones on the moon are still there. So it's a record of the same kind of cosmic bombardment that the Earth has received. You can just still see all the scars there where the Earth has erased most of its. Down on the surface, it's a powdery soil, rocks. This is a photo from one of the Apollo landings, setting up a little science instrument there on the moon. But again, no clouds, no atmosphere, no sign of rain, no little channels from rain runoff. It's just an airless, lifeless world. So no atmosphere at all. If you take off your helmet, you're unconscious in about 5 seconds. Because the Earth or the moon always keeps the same face toward the Earth as it goes around the Earth, it makes a circle around the Earth about once a month, and that means that if you're on the moon, the sun is up for 2 weeks, and then it's down for 2 weeks. And because there's no atmosphere or clouds or water to absorb heat during the day and release heat during the night, which is what happens on Earth, it keeps the day-night cycles for the temperature from getting very hot in the day and very cold at night. Plus, it's a very long day and night on the moon. At noon on the equator, it's about 120 degrees C. Of course, there's no air temperature. That's the temperature of the soil. And then at night, it cools off to about minus 180 degrees C. So incredible temperature swings. No form of life on Earth can grow in those conditions. There are microbes that you can put there, and they'll make a little cyst, and they can hang out for a while, but they can't grow and reproduce under those conditions. All right, so the moon's not really a very hospitable place for humans. What about out further in the solar system? This is the planet Venus. This is our nearest neighbor in space to the Earth, and in fact, it's about a twin of the Earth. It's about the same size as Earth, but since the first time we pointed telescopes at it, we saw the picture on the upper left there. It is completely covered in clouds, so you can't see what's going on down on the surface at all. The clouds are completely opaque. They cover the entire planet. You can never see the surface. So in order to figure out what's going on, and of course we couldn't see there, so in all the science fiction from the 1950s, we figured out, it's all cloudy on Venus. What kind of environments on Earth are really cloudy? Well, jungles and stuff. So maybe there's like jungles full of dinosaurs down there on Venus. Not so much, and we'll get to that in a minute. If we really want to know what's going on under those clouds, we have to use radar. So the Magellan mission in the late 80s, early 90s went into orbit around Venus, mapped through the clouds using radar, and built up that picture of what Venus looks like under the clouds. Nothing like a sea or ocean. It's all a rocky surface, and the radar data is black and white. So they've artificially colored this image, this kind of cheerful orange color, and I'll talk about in just a minute why they picked that cheerful orange color for Venus. The Russians have sent a couple of probes in the 1970s that went down to the surface. They survived for a couple of hours down there and were able to transmit a couple of pictures. And what you can see is kind of a gravelly surface. This is actually the surface of an ancient lava flow, so you can see some kind of plates of lava. And the triangles down there at the bottom are part of the spacecraft that was in front of the camera's field of view. So, that atmosphere of Venus with the clouds you can't see through is 90 times as massive as the atmosphere of the Earth. That means if you were standing on the surface of Venus, the pressure of the air would be the same as the pressure if you were 3,000 feet down, 1,000 meters deep in the ocean. So, we can send armored submersibles, and there's a couple of kind of armored suits that you can use to descend that deep in water. But you'd need heavy armor just to withstand the pressure of the atmosphere. And I'm told that if you were strong enough and you hold a ping pong paddle, for table tennis, in each hand on Venus, you could fly. because the air is so thick. But of course, you wouldn't be strong enough because you can't lift your own weight on your arms. That atmosphere is mostly carbon dioxide. There's no oxygen at all in the atmosphere of Venus, so nothing that can support life. It is all carbon dioxide, and those pretty clouds are made of concentrated sulfuric acid. So you think acid rain on Earth is bad. Venus has it in spades. And in fact, if you're going to design something that's going to parachute down to the surface of Venus after entering the atmosphere, the parachute has to be built out of a cloth that can withstand being bathed in sulfuric acid. And the worst part's the temperature. So that thick atmosphere is a really good insulator, which means no matter where you go on Venus, the temperature is always the same. Go to the pole, go to the equator, doesn't really matter. If you go up on a mountaintop, it might be a little bit cooler. But that thick atmosphere is such an effective blanket that the temperature is the same everywhere on the surface of Venus. And that is the reason they chose that cheerful orange color for the surface of Venus, because the rocks glow like the heating element in an electric oven at 450 degrees C. That's the actual color you would see. And even your armored suit isn't going to save you from that for very long. So Venus is really, really bad place to go. The solid part of Venus is a twin of the Earth. The atmosphere of Venus is like hell. We don't want to go there. All right, well, that was horrible. How about Mars? Everybody likes to talk about Mars. Notice everybody talks about exploring Mars. Nobody talks about exploring Venus. That's why. Nobody wants to go there. I have seen a proposal that you're going to fly in from deep space, enter Venus's atmosphere, and then as you're plummeting down through these sulfuric acid clouds, you'll pop out a balloon, and then you'll float among the sulfuric acid clouds of Venus, and really, really, really hope that your balloon does not spring a leak, because if you go down there, you're going to die. And then, oh, by the way, coming home, you'd have to launch off a planet, which takes a rocket about as big as it takes to launch off of Earth, from a balloon. Let's go to Mars. All right. So, Mars has a couple of small moons. Earth has a big moon, almost a planet-sized moon. Mars has a couple of little captured asteroids. This is Phobos against the surface of Mars behind it. Mars has a lot of impact craters, but you can already see that it doesn't have as many as the moon. So Mars has an atmosphere, and it can raise dust storms and move sand and dust around. And when we started exploring Mars a little bit more carefully with spacecraft, we discovered that it looks like it tried to have plate tectonics, tried to have sections of the crust move around. This is the Mariner Valleys, and it looks like Mars split, but there was only one plate, so there's nowhere for it to go. So it didn't quite develop plate tectonics. Instead, we have a canyon that's 5,000 kilometers long across one side of Mars. And down on the surface, it looks like that. So that's an impact crater up there that's filled with dust. These little brown patches are places where the spacecraft, which was in a cocoon of airbags, came bouncing down, and it hit there, and hit there, and hit there, and kind of rolled over here, and then it opened up. But you can see most of the surface is not made out of impact craters. So things have been going on Mars that erase some of the impacts. You can see that Mars has an atmosphere, kind of an orange tinge to the sky, but it's 6 millibars, so less than 1% as dense as Earth's atmosphere. Anybody ever see the movie Total Recall? Don't rush out. It's not very good. Those of us of a certain age, yeah. Anyway, if you take your helmet off on Mars, you're just as dead, just as fast as if you took your helmet off on the moon, but your face is not going to actually swell up. That's nonsense. Not everything you see in the movies is true. Mars' atmosphere also is made out of carbon dioxide. You may notice a pattern here. All Earth-like planets except the Earth have an atmosphere that's made out of carbon dioxide. There's no oxygen in Mars' atmosphere, nothing to support human life, and there's enough wind at certain seasons that it can raise dust storms that actually cover the whole planet in dust, and our spacecraft in orbit can't even see down to the surface. The temperatures on Mars are less bad than they are on the moon. That atmosphere does moderate the temperatures just a little bit. On a hot summer day in full sun on the equator, it can get up to about 35 degrees C. But that thin atmosphere does not hold much heat at night. So even though Mars's day is only 24 hours and 50 minutes, very similar to the Earth rotation period, it gets really cold at night, and especially in the polar regions. It's extremely cold. All right, next planet out, further away from Earth, is Mercury, closest to the sun, and it takes an expert to tell a picture of Mercury from a picture of the moon. It's another airless world. We've never put a lander on the surface, so we don't know exactly what it looks like at the surface, but it probably looks a lot like the moon, because from orbit, it looks a lot like the moon. A little bit more of a close-up, so you can see there are places that are not all covered with craters. There's these plains and some strange little ridges and stuff like that, but basically it's very, very hard to tell the difference between these two worlds, and their surface conditions are not too different. No atmosphere at all. There's a few sodium atoms from the sun that might hit Mercury and bounce around the surface for a little while before they get stripped away by the solar wind, but that's only a few atoms, not enough to breathe. And the temperature swings are horrible. Because Mercury is closest to the sun, the day side, when it passes closest to the sun, can get up to 425 degrees C. Notice that even though Mercury is much closer to the sun than Venus, Venus is hotter than Mercury, and it's because that thick carbon dioxide atmosphere traps so much heat. So the hottest place in the solar system is not the closest place to the sun. It's the second closest planet to the sun. And then, of course, with no atmosphere to hold the heat, Mars's days and nights are 55 days long each. So the sun spends a long time in the sky, and then it goes down and spends a long time below the horizon, and you get down to about minus 200 degrees C at night. Not a good place. So that clears out the inner solar system for potential other places to go. Let's take a look at the outer solar system. This is the planet Jupiter. It's about 10 times larger than the Earth. This is an artist's impression of what it might look like if you were down floating among the tops of those clouds. When you look at Jupiter from space, all you're seeing is the tops of clouds. And if you were to descend through those clouds, the atmosphere would get thicker and hotter and thicker and hotter until it would melt any material we can make and crush any spacecraft that we could build. So there's no way down in the center of that planet, 10 times the size of the Earth. There's a little rocky center down in there, probably about the size of the Earth, but the temperature down there is like 70,000 degrees C. You can't stand on it. So there's no surface to stand on, no solid surface that you could stand on if you went to Jupiter. Oh, by the way, the gravity is 2.5 times on Earth, so your body would weigh more than twice what it does here if you were somehow floating in a balloon amongst those clouds. So that atmosphere is made out of hydrogen and helium, largely the same elements that the sun is made out of. No oxygen at all, and not even any carbon dioxide. Those heavier elements like carbon and oxygen have all sunk down into the center of Jupiter, just leaving the lightest elements in that atmosphere. There's no oxygen to speak of. But Jupiter has 4 moons that are about the size of planets. At least they have a surface you can stand on. So let's take a look at them. This is Io. A lot of Greek names. You have had more global influence than you may realize. This is Europa. We think there's an ocean of liquid water underneath that shell of ice, and that's a good place to go looking for life. And in fact, somebody asked about planetary protection. For 15 years or so, the Galileo probe orbited the planet Jupiter, studying the moons, studying the planets in the magnetic field. And then when we were done with it, we deliberately ditched it into Jupiter so that it wouldn't hit Europa and contaminate Europa, because we think Europa is a good place to look for life, and we don't want to go there and find, human gut bacteria. That's so embarrassing. So we don't want to do that. Ganymede, largest moon in the solar system. It's actually larger than the planet Mercury. That also has a thick icy shell and might have some liquid water very deep underneath it. And Callisto. So those are those 4 big satellites. And conditions on them are pretty similar to each other. If you were standing on the surface, you would see, especially on the outer ones, a lot of impact craters, hills, rubbly surface, and then no atmosphere, but Jupiter in the background. So no atmosphere at all, just as dead, just as fast if you take your helmet off there as the moon or Mars. And it's really freaking cold because you're really far from the sun. So high temperature is about minus 150 degrees C. Low temperature is about minus 220. And oh, by the way, at Io and Europa, the radiation fields around Jupiter. Jupiter has a tremendous magnetic field, which traps a lot of space radiation, and it's concentrated around the moon, orbits of those two moons. And if you were to go there, you would receive a killing dose of radiation in a few hours. And so then over the next few days, you'd get really sick and your hair would fall out, and that's all. So we don't want to really go there until we can protect ourselves from that radiation. And it's really cold. Moving further out in the solar system, the planet Saturn has those amazing rings. This is an artist's impression of what it might look like if you were floating amongst the clouds of Saturn. Saturn has the same problem as Jupiter. There's no solid surface. The atmosphere just gets thicker and hotter and thicker and hotter the further down you go, and long before you would reach the little Earth-sized core of rock in the center, the temperature would be tens of thousands of degrees C, and the pressure would crush anything that we can build. And the artist has included two of the little shepherd moons there that keep that little ring. So Saturn, some of Saturn's rings are kept in place by two little moons, one on either side. And so the artist put that in there. Saturn has a big moon called Titan. And Titan has an atmosphere. And the European Space Agency sent the Huygens probe down onto the surface of Titan. And it took some pictures before the cold wiped it out. And that's what it looks like on the surface. That orange haze is the same orange of smog that you see in a big city on Earth, and made for the same reason. The atmosphere has some hydrocarbons in it, and ultraviolet light from the sun converts those hydrocarbons into that smog. But these rocks are water ice. So the main mineral on Titan, because it's so cold, is H2O water ice. So Titan's atmosphere is actually really interesting, and a lot of people think it's a model for the atmosphere of the Earth before life arose. It's got about 1.5 times the pressure of Earth's atmosphere, and that's totally manageable. If we increased the pressure in this room 50% to make it 1.5, everybody would feel completely normal. Your ears would pop a few times as the pressure was going up, but that's like being 5 meters deep in water. So 5 meters of water adds that 50%, and you'd be absolutely fine, and you could live the rest of your life that way, and it would be just perfect. However, the atmosphere is nitrogen, which we're breathing all the time, but it's more of an inert gas. Our body doesn't use it. There's no oxygen. I talked about the smog. And it rains on Titan. And we've actually seen little river channels and lakes and seas, but the rain is methane because it's really cold, and you don't want to drink that. And that thick atmosphere does a great job of moderating the temperature all over the moon. The temperature is about minus 180 degrees C. So it's like a frozen version of an early Earth. Less bad than anywhere else we've seen besides the Earth, but still not hospitable to life. Going further out into the solar system, Uranus and Neptune. Same story as Jupiter and Saturn. No solid surface, it just gets hotter and denser, and eventually it will crush your spacecraft or whatever it is you're riding in. Neptune has a moon called Triton, which also is as big as a planet, but it is airless, and it's a pretty good model actually for the ex-planet Pluto. Very tiny world, very far out in the solar system. Pluto does have a tiny thin atmosphere, just barely above a vacuum. When we sent the New Horizons probe past Pluto, it looked back and saw the atmosphere backlit by the sun, and you can see there's some very thin layers of haze there. But that atmosphere is close to nothing, much thinner than Mars's atmosphere, nothing there that you could breathe. And it's really cold because you're really far from the sun. Pluto is about 40 times further from the sun than the Earth is. All right, that's pretty much all the major bodies of the solar system, and most of them are horrible. And the one that's the least horrible, Mars is maybe manageable, and Titan is maybe manageable. So how about planets around other stars? You can't read the newspaper anymore without seeing that they've discovered some planets around other stars. And so the discoveries are coming in thick and fast. Now, it would be nice if we could get there, but we can't. And there are some problems with most of those worlds. Now, admittedly, the methods that we are using to find planets around stars other than the sun are most sensitive to big planets that are really close to the star, and I mean really close to the star. And one of the features that they expect to find on many of these worlds that we're finding is silicate rain. Silicate is how Planetary scientists says rocks. And these planets are so hot that not only does the heat from the star melt the entire surface of the planet, so the whole thing is an ocean of lava, it boils the lava ocean, and vaporized rock rises up, makes clouds, and rains down molten rock. This is not a good place to go. So even if we could travel to other stars, there have been a few discoveries of planets that are more similar to Earth, but again, the majority, but because that's what our methods are good at finding, are finding us worlds that have silicate rain. So let's summarize that trip through the solar system. Half the planets in the solar system have no surface you can stand on. The rest are either too hot or too cold. They either have too much atmosphere or too little or none at all. And it doesn't contain any oxygen. And under those conditions, you are unconscious in 7 seconds, and you're brain dead in 3 minutes. And that's if you're not on Venus, because Venus will burn you up before 3 minutes go by. So, the Earth is precious, and everywhere else is horrible. But wait, it gets better. We've been studying Mars for a long time now. Our first space missions went past Mars to take pictures over 50 years ago. And we have 3 rovers and half dozen or 7 orbiters going around Mars right now, all studying the planet. And when we looked at it closely, we started seeing things like this. That is a branched river valley, just like a river valley on Earth. You can't make this except by applying liquid to the surface over a wide area and having gravity pull it together and flow downhill. That means rain, and that means some kind of liquid that could act as rain, and it's not hot enough for silicate rain. And the only material on Mars that can be liquid that exists in enough quantity to make river valleys is water. So these are old things, and you can see there are impact craters on top of the river valley. So that means they happened after that river valley was formed. So this is old terrain we're looking at, billions of years old. But somehow there was rain on Mars in enough quantity to make river valleys in the past. And right now, Mars, if you put a cup of water on Mars, it would boil until it froze. The atmospheric pressure is so low that at room temperature, water boils, but it would cool off quickly and then freeze. So you can't have liquid water on the surface of Mars today. But you can in the past, could in the past, evidently. And we think that most of the water that Mars had is now locked up in its polar caps in the north and south poles. So what we think happened is that long ago, Mars had a thicker carbon dioxide atmosphere, and on Mars, greenhouse effect is a good thing because it's really cold, and that made the temperature warm enough and the air pressure high enough that liquid rain could fall and flow across the surface in rivers. But Mars is a small planet. It has less gravity than the Earth, and that means its atmosphere is always escaping into space. It also has no magnetic field, and somebody was asking about magnetic field earlier. And that means that the solar wind just hits the top of the atmosphere, and that ionizes atoms and strips them away. So Mars's atmosphere is always getting blown away into space. When the atmosphere gets thinner, there's less greenhouse effect, the temperature goes down. The water snows out at the poles. Water vapor is also a good greenhouse gas. The water snows out, the greenhouse effect gets less, it gets colder. More water snows out. Then it gets cold enough that the carbon dioxide freezes to make dry ice. And pretty soon the whole atmosphere freezes and collapses onto the poles, and what you've got left is a near vacuum, which is what we see today. And we call that the runaway refrigerator effect. It builds on itself. As the atmosphere collapses, the warming effect of the atmosphere only causes the atmosphere to collapse faster. So the take-home message here is Mars was once warm enough for liquid water, and it had an atmosphere thick enough to support that, and it doesn't today. Something bad happened to it. There is a comparable story for Venus. When we've studied Venus's atmosphere, we find that it has some hydrogen in it, and the isotopes of that hydrogen are unlike anything we see on Earth. There's a lot of deuterium, which is heavy hydrogen, hydrogen with an extra neutron in there. And it has like thousands and thousands of times more heavy hydrogen than water and hydrogen on the Earth. And what we think happened on Venus is that long ago it had enough hydrogen, which when mixed with the oxygen that's present in any rocky planet, would have been enough to make an ocean. So Venus had an ocean's worth of water on it long ago in the past, but it went away. Venus's atmosphere is also not protected by a magnetic field. The solar wind strikes it, and any water vapor in that atmosphere gets split apart into the hydrogen and oxygen. Hydrogen is really light. It escapes into space easily. The oxygen and the deuterium, which is heavier, remain behind. So what we think happened on Venus is it could have had an ocean of water and a thin carbon dioxide atmosphere, but as the temperature increased, carbon dioxide can get baked out of the rocks, and the temperature increases until it boils the ocean. Then the ocean water becomes part of the atmosphere. It's a great greenhouse gas. The temperature explodes, all the water boils off, and you're left with a dry, rocky planet. Then the water vapor in the atmosphere gets split by the solar wind. The hydrogen escapes to space, and all you're left with is the carbon dioxide. So that's a runaway greenhouse effect. We talk about the greenhouse effect on Earth, and actually everybody talks about it as bad, but the equilibrium temperature of the Earth without any carbon dioxide in our atmosphere is about 40 degrees below zero. You want a little bit of carbon dioxide in your atmosphere. Otherwise, it is really nasty cold. But you don't want too much because of the problems that we're seeing today. So interestingly enough, the Earth has one Venus atmosphere worth of carbon dioxide on it. That carbon dioxide is mostly locked up in carbonate rocks, like the cliffs of Dover here in Britain. If we baked all the carbon dioxide out of all the limestone on Earth, we would have a Venus atmosphere. So we really want to keep that carbon dioxide mostly in the rocks. There's a little bit of carbon in the petroleum we're burning, and that's causing the problems that we're seeing today. But we have a whole Venus worth of problem here that we should strive to keep where it is. We like it this way. All right. The Earth is precious. Everywhere else is horrible. And we have two examples in our own solar system of environments that could have been livable in the past that went away. So because you have a livable environment now, doesn't mean you always will. We have examples that show that can stop happening, and you can end up with a planet that does not support life, even though it did in the past. All right. Next stop, our atmosphere is something we take for granted. We talk about carbon dioxide and other pollutants in the atmosphere, but I want to talk for a little bit about the oxygen in the atmosphere. If we took all the oxygen out of the atmosphere, unconscious in 7 seconds, brain dead in 3 minutes. Okay? Even if we still have the normal temperature and all the nitrogen and stuff like that, you need oxygen to live. In fact, any living thing with more than one cell needs oxygen to live. 2.5 billion years ago, if you had stepped out of a spacecraft onto the surface of the Earth and observed this scene with the volcanoes and the stromatolites, these are bacterial colonies that were one of the first forms of life to arise on Earth, you would have been unconscious in 7 seconds, brain dead in 3 minutes. Because there is no oxygen in the atmosphere until nature invented blue-green algae, single-celled critters in the ocean, that started pumping out oxygen as a waste product. And there must have been a horrible time in the Earth's past when oxygen, which was a poison to almost all life forms at the time, killed off almost all the life forms at the time. We still have a few bacteria that don't need oxygen. Actually, oxygen is poison to them, and they live, like if you dig around in low-tide mud and it starts smelling really bad, like sulfur, that's bacteria that don't like oxygen. Around 2.2 billion years ago, the oxygen in the Earth's atmosphere started to increase, and when it did, the iron that was dissolved in the Earth's ocean formed iron oxide, or rust, and began to sink down to the bottom of the ocean. And there are mineral deposits in various parts of the world called banded iron formations. And this is one. Ta-da! That's up in Michigan, source of a lot of iron mines. And all this is iron that was in the ocean that combined with the new oxygen in the atmosphere and settled out, and now it's a good iron deposit. So the lesson there is, if you think you're going to go to a planet with no life on it and step out of your spacecraft and talk to your robot or whatever, you are sorely mistaken. If you can breathe the air, that air was made by life. There is no such thing as a lifeless planet with a breathable atmosphere. The only thing that can make the oxygen that we need to survive is life. So we depend on the Earth's biosphere for the oxygen that we need to survive. And there's nowhere else in space where you're going to find an oxygen atmosphere unless there's already somebody living there. All right, it gets better. So in 2008, I got to fly on the space shuttle. There I am in space. That's my younger brother. But a more famous mission, my mission wasn't famous because everything went pretty well. But famously on Apollo 13, they had an explosion in their service module that contained most of the supplies they needed to fly to the moon and back, and tore the whole side off the spacecraft. And we did get those guys back safely, but it's a very heroic story. And the Apollo 13 movie, that is one you should rush out and see if you haven't seen it, because it's very well done. And famously, Mission Control had to figure out a way to scrub out the carbon dioxide from the atmosphere in the spacecraft that the astronauts were breathing out. They had enough oxygen to breathe in, but once you start breathing carbon dioxide out, it doesn't take very long in a sealed spacecraft for the carbon dioxide levels to make you very sick and eventually kill you. So the problem wasn't supplying the oxygen, the problem was getting rid of the carbon dioxide. And they had carbon dioxide absorption canisters that were designed square on one side of the spacecraft and round on the other. And the round ones, that part of the spacecraft didn't work anymore, so they had to adapt the carbon dioxide absorbers for one side of the spacecraft to operate on the other side using a plastic bag and duct tape. And that's how NASA gets famous, because we solve problems with plastic bags and duct tape quite a lot. Carbon dioxide removal remains one of the biggest challenges of human spaceflight. Every spacecraft has to have it, including the International Space Station, where we have 6 people living right now. And everybody who goes to the International Space Station gets to spend every few months about a day of quality time with the CDRA, Carbon Dioxide Removal Assembly. This is CDRA. It's this huge thing. It's about 2 meters tall, 1.5 meters wide. It's got all these friendly little purple valves on it. And here's Jeff Williams fixing the CDRA. CDRA breaks all the time. A flight control joke. When we first brought up the regenerative life support system on the space station, which can actually recycle some of the water, recycles the carbon dioxide, actually split out the carbon dioxide and get the oxygen back so that we can breathe it again, splits the water, gets the oxygen back so we can breathe it again, dumps the hydrogen and methane overboard. That system broke so often that the flight controllers who are in charge of that system, ECLS, Environmental Control and Life Support, were kind of ashamed about it. And the people sitting next to them, the thermal control engineers, the Thors, made this joke picture of the caution and warning board on the station that says, here's everything that's going wrong with the station now, here's what needs your attention. And they said, caution, regenerative life support not failed. Because it was normal for it to be failed. So absolutely famous, and it breaks all the time. And if some totally creative person in this room wants to make a space toilet that doesn't break all the time, we would love a space toilet that doesn't break all the time. All right, so carbon dioxide removal assembly and all those life support systems break all the time. And actually, that's a little bit unfair. So the other systems on board the spacecraft, power, propulsion, thermal control, data handling, communications, every satellite, every communication satellite, the GPS constellation, every single spacecraft, all our planetary ships have all those systems on them. And we have thousands and thousands of years of spacecraft time accumulated because we have all those spacecraft flying on all those systems. So we're pretty good at it. But only a few spacecraft have the life support system on them. And we have maybe 50 years of total runtime on spacecraft life support systems. So this technology is in its infancy, and that's why it's so failure prone. All those other systems, they had all their failures in the 1960s, and then they figured out how to do it right, and these days they do it right. So I tease the life support systems, but they're about where they should be given how young they are. This is Biosphere 2, which is a sealed environment built in the desert of Arizona. The idea is that the Earth is Biosphere 1, and that is Biosphere 2. A full discussion of this would take a full hour. But in the 1990s, they carefully built a replica of the Earth's biosphere in there with a jungle and farming fields and an ocean with a coral reef and all this amazing thing. And they were going to seal 8 people in there with it. And the biosphere was going to grow their food. It was going to recycle their carbon dioxide. It was going to process their waste back into soil. So with great fanfare, they sealed their 8 bionauts into here, and everything went wrong. So first thing that happened is all the butterflies died. The population of the ants and the cockroaches exploded. A bunch of the food plants died. They were carefully sampling the environment all the time, and they started finding like weird, nasty agricultural chemicals in this specially created environment that they had not put there. And the chemicals, it turned out, were coming out of the body fat of the bionauts because they were losing so much weight because they weren't getting enough to eat from this biosphere. And you can see, that's for a spacecraft, that's gigantic. We can't build anything that big and fly it in space. And that tried to support 8 people, and it failed. So there were also terrible management problems, and there were terrible teaming problems with the bionauts themselves. And then, it wasn't just a technical problem, but then the very worst thing is the oxygen levels inside this sealed habitat plummeted. Like it got dangerously hypoxic in there, like being at high altitude. And nobody knew why, and they had to pump in extra oxygen to keep the bionauts alive. This is a sign that things are not going well. They have to pump in extra oxygen. It's like you're in the hospital. Okay. They think what happened was the concrete was having some sort of chemical reaction with the oxygen and sucking up the oxygen inside the habitat. Anyway, they had to come out early, and the facility still exists, and they're still doing research on it, but nobody's talking about putting 8 bionauts in it. And this was 30 years ago, and we still haven't solved this problem. Not a great success story, but one that we pay very close attention to in spaceflight, because when they say, oh, we're going to fly to Mars and we're going to grow our crops on board. Not till you show me that works on Earth. Then we'll talk about taking it to Mars with all the other problems that you have in spaceflight. So, take-home message from Apollo 13, the Seadra, and Biosphere 2, artificial replacements always fail. It's a fact of life. So, that's my story for you. So with that, that's the background that I look at a picture like this. This is the system that used to recycle my air and water. It doesn't do that anymore. Now there's more of it, but I don't really want to see any of it looking like this, because this is not making my air breathable or purifying my water anymore. That's my drinking water supply. I don't want to see that. I would like clean water, and a hallmark of clean water is it does not kill the fish. That's my breathing air. I don't want to breathe that. I don't want to see what I'm breathing. So, this is the concentration of carbon dioxide in the Earth's atmosphere. This graph was made in about 2015. We are now well above 400 parts per million in the atmosphere. And you can see, so the little wiggles, by the way, are every summer in the northern hemisphere, which is mostly land. The forests grow all their new leaves, sucks down some carbon dioxide. In the winter, all the leaves fall and decay, and then the carbon dioxide comes up as that carbon is released back into the atmosphere. So what you're seeing here with these little wiggles is the northern hemisphere forests breathing, and the total carbon dioxide keeps going up and up and up, and we're now, and somewhere up there is Venus. It's a long way. The Earth has been 10 degrees C hotter in its past. There have been jungles at the poles in the past, and it was okay. It was really hot, and you had jungles at the poles, but the Earth's biosphere survived. People probably wouldn't. Among other things, our food crops wouldn't do well under those conditions. The Earth's biosphere will be just fine. We are heavily invested in the current biosphere. But anyway, somewhere up there is Venus, and I don't want to go there. So, I would like to leave you with a quote from my role model, Carl Sagan. Anything else you're interested in is not going to happen. If you can't breathe the air and drink the water, don't sit this one out. Do something. Your move. Thank you. All right. It is almost 2 o'clock, so I think anybody who must leave, you're free to go, but I will answer questions for a few minutes, but don't feel you must stay for them, because we are way, way behind schedule, and the only thing standing between you and lunch is me.
First of all, thank you for your presentation. I would like to say before asking my questions that you should quote your phrase that I don't want to see what I'm breathing. It should be a quote from now on.
Thank you.
And I have 2 questions. The first one regards the magnetic fields. So how are magnetic fields created if we have one and Venus doesn't have one and Mercury doesn't have one? Why do they not have one? And if they don't have one, how did they have water in the past before the solar eclipse, the solar flares extinguished it all?
Got it. Okay, so first of all, nobody knows how planets make magnetic fields. The first person who figures that one out can probably collect a big prize. But we think it comes from heat escaping from the core of a planet that has liquid metal inside, molten iron inside. And the heat escaping makes it boil like a pot, like a hot pot on the stove. And the movement of a conducting fluid creates a magnetic field. So the moon doesn't have one because the moon is solid all the way through. It cooled off long ago. It has no liquid center anymore. Or if it does, it's too small. Same thing with Mars. Venus, we think, has a liquid center, but it rotates so slowly. The Earth turns quickly. Venus rotates every 270 days that it can't create a magnetic field. And Mercury actually has a magnetic field. Mercury's magnetic field can stand off the solar wind, but it's just so hot that an atmosphere boils off. And also Mercury is very small and doesn't have the gravity to hold that atmosphere. So Mars and Venus could have held on to water for hundreds of millions of years before the lack of the magnetic field allowed the solar wind to strip. So it takes hundreds of millions or billions of years for the solar wind to strip away an atmosphere without a magnetic field. So there would have been a time before that happened where they could have retained that atmosphere, retained some water. But then over time, as the magnetic field decreases, or as the solar wind keeps blowing away the atmosphere, none is left after a long time. That make sense?
And the second question regards the growing of crops or whatever on the spaceships. So what if could we grow crops that are not plants like mushrooms, so that we don't have to consume oxygen and stuff like that, and maybe we could recycle nitrogen in the form of human feces and stuff.
There are several cycles that we want to close, material cycles that we want to close in space. It turns out the first one is water. So it takes a small area of plant leaves, because leaves are always transpiring water. They can purify water for you. So if you are using plants in space, the first benefit that you get is you can recycle your water. Then it takes a larger area of plants to recycle your oxygen and carbon dioxide. And then it takes a much, much larger to recycle your waste back into food. You need a small field to recycle your water, a larger field to recycle your oxygen, and then a giant field to recycle your food. So mushrooms are also a crop that is subject to failure, but they address only the waste to food part of the cycle. And if I'm going to grow crops, I want to get my water and oxygen with it. So I want to start with those and then go to producing the food from the human waste. Does that make sense? But the main problem is supplying the energy for a farm like that. And of course, Biosphere 2 had all the energy they wanted. They were in a greenhouse in Arizona. But the lighting it takes to grow enough crops to feed one person is millions of watts. And no spacecraft has that. The International Space Station, 6 people living on board, use 100,000 watts of power. And so we need a spaceship with at least 10 times as much power generation to make that happen. And we're not there yet.
Again, something on the topic of geomagnetic fields.
Okay.
Are we ready for the next solar flare?
No.
No.
So solar flares happen all the time.
Will we survive like the big one in the 19th century?
Yeah, that will be hard. People are talking about that. So in the late 1800s, it was called the Carrington event. The sun had a gigantic outburst, and telegraph operators sitting at their telegraph machines were burned because the Earth's magnetic field was compressed. It generated electric currents in all the electric wires all over the world, and basically, all the telegraph sets exploded. Now we have way more wires and way more stuff connected to them, and it would be bad. But I do hear people talking about this a lot. I hope somebody's paying attention. I have surge protectors at home. And frankly, I worry more about lightning than Carrington events because I get lightning all the time. We live in Houston. But yes, that is a very serious problem, and it's worth looking at.
What are the chances that it happens in our lifetime?
Well, let's see. There was one, and it's been 140 years, so maybe 0.7.
Hello.
Hi.
I would like to ask you, since that you showed 2 slides, one with the Enterprise,
Yeah.
and you said that there are planets that can support human life.
They're better.
Well,
They have
possibly.
normal temperatures, but we don't know what's in the atmosphere.
Possibly, though.
Yeah.
I would like to ask you, what is NASA? NASA has done any research on building an engine that can go to a higher speed than rockets today?
Yes.
And
So yes, we've done that research.
what
Actually,
stage is it?
the last thing that looked like a breakthrough, nobody else could make it work. So generally, if another laboratory can reproduce it, it's good. If other people try and it doesn't work, it doesn't work. So that laboratory actually is at Johnson Space Center where I work, and I've met the guy who did the experiment. And it seemed in experiments they had actually an enclosed microwave chamber, and they ran a bunch of electrical power through it, and it produced thrust without exhaust. Oh, that makes us very excited. If we can make thrust without exhaust, now we don't have to carry these gigantic tanks of propellant. But it doesn't work. So, lots of people are looking at it, but unfortunately, right now, there is nothing we know of in the laws of physics that will allow us to travel to another star in a reasonable time frame. Now, we always find out new things about physics. It surprises us. But right now, we don't have anything to go on. I'm sorry. I love science fiction. I wish we could go. But.
May I add something? Warp drive isn't that much out of imagination, right? I mean, there are physics, to some extent, it is from a physics perspective possible.
There are some things in physics that make us think it's possible. Are you talking about the
warp drive?
Alcubierre warp drive or Star Trek warp drive? The Star Trek warp drive they made up. There's a thing called the Alcubierre warp drive, which shrinks space ahead of the spacecraft and expands space behind it. And there are some equations that suggest that could work, but we don't know how to shrink space and expand it. There is theoretical support for wormholes that allow you to travel instantaneously from one place in the universe to another. But I attended a lecture when I was at Caltech from Kip Thorne, who is the world's renowned expert on black holes. You've probably heard of Stephen Hawking. You probably haven't heard of Kip Thorne, but they would bet each other things and win from each other. Anyway, Professor Thorne described a practical wormhole. If you built a conducting metal sphere the size of the orbit of Pluto, and then just outside that, you construct another giant metal sphere the size of the orbit of Pluto, and the space between them is one atom, 1 angstrom wide. You can no longer tell which one is the inside and which one is the outside, and after this construction project, you can travel a distance of 1 angstrom. Not practical, but the equations work. Because when you put two conducting plates very, very close to each other, there's a force called the Casimir effect that produces a negative pressure, and warping space takes a lot of negative pressure. Read up on it. It's complicated. I won't spend any more time on it. But so there's hints, but nothing practical.
Okay, thank you.
Sure. Oh.
Hi.
Oh, wait, hang on. We're getting a microphone. Yes? Let's see. We only have the one microphone? Oh, okay. All right, go.
All right. So Elon Musk proposed to shoot with nukes the poles of Mars to heat it up and create an earthly-friendly, human-friendly atmosphere. Will that work? What's your opinion about it?
Oh.
No. Why though?
First of all, it might be a little radioactive. And that's not good either. So my favorite factoid about terraforming Mars, and there was a special issue of Nature magazine back in the 90s that talked about terraforming Mars. If you took all of the sunlight that ever hits Mars in a year, right? So a solar collector the size of the planet Mars, and you kept all that energy on Mars. None of it was reflected into space. None of it went to melting the ice caps. You just kept all that energy and used it only to heat up Mars with no loss and no escape. It would take 100 years to bring the planet Mars up to the melting point of ice.
All right, thank you.
Yeah, it's not going to be quick. It's not going to be easy.
Too bad.
And I don't think anybody's going to really want to move there until there's beaches and fruit. Seriously.
Couldn't that happen if we created a simulation of the greenhouse effect by bringing too much CO2 to Mars to increase the temperature?
So I haven't seen a simulation of that. Actually, the best treatment I've seen it in fiction is the trilogy Red Mars, Green Mars, Blue Mars by Kim Stanley Robinson. That is a well-researched book, but you will have to use every trick in the book to heat up Mars, and it's going to take centuries to make that happen. And Mars may have enough carbon dioxide left that if we augmented it a little bit, we could make an atmosphere that was thick enough to make liquid water possible again. We don't really know how much carbon dioxide Mars has locked up in the polar caps. So it may be enough there already. We just don't know.
Hello?
Yes?
Here? Here.
Look it up there. Okay, go, sir.
So I would like to ask what was the longest period you've spent in space so far? What did you do to entertain yourself during this period? And what was the greatest emotion you had and the worst you've experienced?
Oh, well, that's 4 questions. All right. So I have only flown in space one time. I was on the space shuttle for 2 weeks. Entertainment was not an issue. We were working all the time. If one had a few minutes, you go to the window and look at the Earth. That's the thing that people want to do the most is look at the Earth. I'll start with my worst experience. My first spacewalk, a lot of things went wrong. I injured my hand trying to work with one of the power tools, and then I had to do the rest of the spacewalk with a hurt hand. And I ran out of drinking water, and you're in the suit for 8 hours doing hard physical work, and you don't want to run out of water. So that was a very difficult experience for me. The best was at the end of my second spacewalk when we'd done all the work, hanging out outside the airlock, waiting to go back inside, and the shuttle and space station flew up over the Pacific Ocean and over Oregon, where I'm from. Even though it was February and the weather's usually horrible, the weather was clear from Canada to Mexico, and I saw the whole west coast of America, it's everywhere that I knew, to come rolling up underneath me, and I'd done all my hard work, so that was a great feeling.
My question is, you said that something happened to the downfall of Mars' atmosphere. Is there any guess that this could happen so we can bring back that atmosphere, not in a human way?
It wasn't one thing that made Mars' atmosphere go away. It was a combination of a small planet with a weak gravity field so the atmosphere can escape into space, and no magnetic field to protect that atmosphere from escaping into space, and then a long period of time. So those processes would have worked over hundreds of millions or a couple of billion years to gradually strip away Mars' atmosphere. It wasn't just one thing, not a switch you could turn on that turned on that we could somehow turn off.
Thank you.
Yeah, good question though. Yes. No.
Now?
Yay!
Yes. We have, it's similar question to what this guy asked. We have seen other planets like Mars and Venus kind of be made unhospitable. How do we know that something similar won't happen to Earth? Like
we don't.
Okay.
Yeah. The Earth's environment should not be taken for granted. You know, things can happen to planets that make them unlivable, and the Earth, that's also possible for the Earth.
I'm not talking about human intervention. About something else, like the cosmic radiation.
Okay, so eventually the sun is going to start expanding, and things will get hot here. There's also actually a long-term, and I mean long-term problem with carbon dioxide on Earth. If the amount of carbon dioxide that's available to the biosphere is small compared to the amount that's locked up in rocks. And if too much gets locked up in rocks, and by the way, carbon dioxide is always being put into the rocks, we're dumping into the atmosphere much faster than it's being removed, and that's the problem. But if too much carbon dioxide gets removed, you end up without a functioning biosphere. And I've seen that, suggestions that that could happen in 500 million years. So not our problem. All right, for the microphone handlers, we've had a lot of questions from men. Can we get some questions from women, please?
Sorry. May I
raise your hand so I can look at you? Yes.
may I ask you a question?
Yes. That was one. You can ask another. Go ahead.
You told us that at some point in Earth's history, most of the organisms living on it died due to the presence of oxygen in the air. So I presume they were anaerobic organisms.
Correct.
Is it possible that such microorganisms existed in the oceans of Venus or in the rivers of Mars?
Yes. It is possible.
Thank you.
Hi.
Hi.
I have read that last year's the speed of the Earth's spin has accelerated, and even though it should not. And I wanted to ask if that's true, and if it has any effects on Earth.
Okay. So the Earth's rotation rate does change from a lot of little effects, and you will never notice it. These are measurements taken with the precision of 1 part in 1 trillion or something like that. I saw that report, and it was attributed to groundwater pumping. So if you change the distribution of mass on Earth, including a lot of agriculture pumping water out of the ground and then having it run down to the ocean, that changes the moment of inertia of the Earth and can actually change the spin rate. So that, I think I read the same article, but they attributed it to groundwater pumping. And the fact that they can tell from the spin of the Earth what we're doing with agriculture tells you 2 things. We're doing a lot with agriculture, and 2, we're really, really, really precise with our measurements of the Earth's rotation rate.
Hello.
Yes, where? Raise your hand.
Yeah.
Gotcha.
First of all, thank you for your speech. It was really interesting. I'm studying to be an environmental engineer.
Good. Thank you in advance. We're leaving you some terrible problems.
I'm hoping that you can solve them. I would like to ask, we've seen films like The Martian. The guy who was stranded on Mars was cultivating his own waste in order to grow food. A, is this possible to be done in Mars? Is this actually possible? And B, how can I, as an environmental engineer who's some of the aspects that I'm studying is about renewable energy resources and waste management. Is NASA or any other space enterprise actively asking for my specialty so I can work for them?
All right, so The Martian, first of all, The Martian was written by a nerd who was interested in space, and he published it 1 chapter at a time on his website originally, and he had space professionals read it and say what he did wrong, and then he went back and fixed it, including 1 astronaut. I haven't identified who this person was yet, but at least 1 astronaut provided Andy Weir feedback on his novel. And growing potatoes in your own waste is possible, but in the book and the movie, the astronaut had no other choice.
Yeah,
I'd like to have some choices, but yes, it's feasible. So not completely crazy. Alternative energy, so we are always interested, and all space agencies and space technology companies are always interested in energy, especially solar. For waste management, though, we're quite a ways away from being able to implement anything other than a plastic bag. So not yet, but you're young. Keep paying attention. And again, there are so many environmental problems on Earth and technical problems on Earth that have application to space. If you choose projects that you think might have an applicability to space, you can develop those things, and there can be some interest in them from the agencies. But right now, for like waste management, we have urgent problems on Earth, and on space, it's like, yeah, no, that's still too hard for us. We're just going to use plastic bags.
Okay.
Yep. Thank you.
Hello once again. I asked the same question to your colleague previously, and it is about the waste management in space during the space expedition programs. And is there an association, some kind of, how would I put it into words? Is there an association, something that puts rules into place for how many things can exist in space in terms of waste, and can we manage it? Because I think that could be a problem in the upcoming years, since commercial flights and privateers have such an influence on space exploration nowadays.
There is a framework of laws that govern what nations can do in space. Not everybody pays attention to them. The Artemis Accords that Dr. McPhee talked about also talk about orbital debris management. So we're already pretty good at not just throwing stuff out there. That's not true of all countries. Don't blow things up in orbit, please. The orbital debris problem is very bad, and nobody knows how to solve it. But so there's frameworks and guidelines, but there's no way of punishing people who do bad. And there's no real limit on how many objects we can put out into space yet. It's really, really big. But there is a lot of trash from early space exploration when people weren't as careful in low Earth orbit. But the danger there, the greatest danger to people, because if there were no people in space, all that orbital debris would gradually spiral in and burn up in the atmosphere. But if a person is in a spacecraft and a piece of debris hits that spacecraft, they're probably going to die. So the main risk to humans, and then the risk to functioning satellites, which is not bad. It's not so bad to kill a satellite as it is to kill a person. And that's happened before, by the way. We had a functioning Iridium satellite get struck by a piece of orbital debris and killed it. So not as bad as killing a person, but those satellites are expensive, and we'd rather not have them destroyed by orbital debris. So I would say our largest environmental problem in space right now is all the debris left over from early exploration when we weren't being careful. Now we're being more careful, but we still have the problem, and it will take thousands of years for that orbital debris to we call drag out. There's a little bit of atmosphere up there, and the piece of debris in orbit runs into a little bit of that, and it gradually lowers the orbit until it enters the atmosphere and burns up. But it's a big deal. I think your earlier question was the environmental impact to the Earth of space activities, which is...
Yeah, it was more about the negatives of the space exploration program, because you only talked about positives, and there are always negatives in everything in life. So that's why I'm asking.
Space is, well, from the just looking at the United States, 0.5% of our federal budget, which is itself a small fraction of the total economic activity of the United States. So much less than 1% of our total economic activity is spaceflight. So if we stopped spaceflight but kept all other polluting industries, you would not notice any difference in the pollution rate. We are tiny. We're microscopic compared to all the other sources of pollution and energy waste and so forth.
Thank you very much.
Sure. Behind you.
Okay, hi.
Hi.
I haven't really understand yet why we are putting so much effort in order to move in other planets if there are so many problems. But let's say that we could go to Mars and we could be nomads there and have babies there and the humankind grow and live there. With so many problems such as radiation and gravity, it's different and all this stuff. Are the humans that are going to live there, how are they going to be and is it worth it? Are we going to be the same?
I don't think people who live on Mars and like it will not be entirely the same as us. And I say that because I've spent some time in Antarctica, and people go to Antarctica for months or maybe a year or two, and then they don't want to go back. You know, they want to go where there's trees and plants and the beach and nectarines. So I don't think we're close to having people really want to go to Mars to live. I think it may happen someday, and there's an advantage. Someday the Earth is going to get hit by an asteroid big enough to eliminate our biosphere. It will happen. Not soon. I study this for a living. I'm not worried. I sleep well at night. But someday it will happen. So if we want the human species to last hundreds of thousands or millions of years, we are going to have to live on more than one planet. Now, it will be very hard. And again, I think the idea of moving to Mars when you're still living in a completely enclosed environment and you never see a fresh fruit or vegetable. All right. We're way over time here, but I want to tell one story about Antarctica. So I was in a field camp in Antarctica for 6 weeks. About 4 weeks into that, we had a resupply flight. So we're living there are 8 of us. We're living in 4 little tents out on the Antarctic ice cap. Temperature's about 40 degrees below zero with the wind chill, and we're out each day searching for meteorites. We got all the food we could ever want, but it's all frozen. After 4 weeks in that camp, the resupply airplane came, and they brought, for 8 of us, 3 apples about that big from New Zealand, and they were kind of wormy and scabby. And we carefully cut those apples up so everybody got exactly 3/8 of an apple, and it was the best apple we ever ate. And that's after 4 weeks without fresh fruits and vegetables. Now imagine the rest of your life. Or imagine saying, hey, I want to move to Mars, and your spouse is going to ask, what are the schools like? So I don't think it's going to happen soon. I think when Mars has beaches and nectarines of its own, rock and roll. But that's hundreds and hundreds of years in the future, provided we start working at it now. And you're right. We don't want to invest 20% of the Earth's economy in terraforming Mars right now because we have problems of our own to solve. And we need to make sure that our environment is survivable in the long term before we build another survivable long-term environment on Mars. But I'm glad people are thinking about it and they're starting to quantify the question. I read a paper. Somebody thought it was important enough to calculate how long it would take for Mars to heat up so that liquid water could exist. Somebody thinks that's important. I think that's important too. I don't expect it in my lifetime, and I think we have other problems on Earth, and I think we better stop talking.
Thank you.
Thank you so
very much. Well, I would like to thank very much our visitors, Dr. Love and Dr. McPhee. I think they enlighten us with scientific answers to all the questions. And I would say that it is the first time that I see this room full of people in a presentation. I am amazed on the people. And I would like to add, as researchers and scientists, we all say to you to open up your wings and dream. But these dreams should be done also with some scientific thoughts and under certain hypotheses and realistic conditions. And this is what I think Dr. Love and Dr. McPhee showed us today on the questions and the problems that you put in front of them. And thank you very much for all these enlightening presentations. Thank you very much.